So let me start. May often arise when it is necessary to connect two or more transformers in a series or parallel, usually to obtain more current or more voltage than is available from only one transformer. It is essential that transformer be properly phased when they are connected in series or parallel. Okay, properly phased, important topic, important factor, that is properly phased. Okay, so when they are connected in series or parallel, transformer may be damaged or ruined if they are connected together improperly. Okay, so series operation, connecting two transformers together to obtain higher voltage is very simple matter. It is only necessary to connect the primaries together in parallel. Okay, so friends, this is the drawing of the series operation I have already drawn, and it is remembering that I have already mentioned what is the meaning of F1. F1 is rated operating frequency of transformer, and F2 is changed operator voltage. Okay, so which properties you need to remember? You need to remember that primaries together in parallel. Okay, friends, you see the primaries are together in parallel. Okay, now let me finish. Another factor is that connect their secondaries in series and to a voltmeter. You see that I have already secondaries is already connected with voltmeter. This is my voltmeter. I write it is 12 volt OC. Okay, so this is secondary and this is connect. Primary together are in series. They are in series form. Okay, so it is clear. Now, if the secondaries are properly phased, the meter will indicate the sum of the secondary voltage. So properly phased secondaries are properly phased. Okay, phased. So secondary are properly phased, then the meter will indicate the same of the secondary voltage. If the meter indicates the difference of the secondary voltages, the connection to one secondaries may be reversed. One of primary winding may be reversed. Let me discuss parallel operators. Okay, and I will solve one problem. Now this is my parallel operators. I think my diagram, if my diagram is correct, wrong, then wrong or correct, you will think. Okay, so what is the parallel operations? If two transformers are to be connected in parallel, the transformer should be alike in every respect. They should have the same number of primary and secondary turns and same number of primary and secondary turns. Okay, maybe secondary and turns are equal or not same. It is according to my diagram, this is not same. The same number of turns. Okay, maybe let's count it. Okay, 1 2 3 4 5. Okay, 1 2 3 4 5. Okay, maybe this is the same number of turns are same. Okay, secondary same number of turns. Okay, And now another factor, same number of primary and secondary terms. Primary terms also same, secondary terms also same. 1 2 3 4 5 6 7. So it is 1 2 3 4 5 6 7. Okay, maybe or okay. So same number of terms. So secondary transformer are not properly phased. Okay, secondary transformer are not properly phased, then properly phased, then properly phased on parallel operation, the result is in a short circuit that burns out the winding. Even if the two transformers of the same make have the same number or letter terminals, it should not be assumed that they will be properly phased or parallel operation. Two phase two transformer are parallel operation. We connect the primaries in parallel and the secondaries in series. Okay, primaries are parallel and primaries are parallel, secondary are series. Secondary are series. Okay, important information. Secondaries are series just as the series operation. Okay, the secondary terminals of one of the transformer are arbitrarily tagged S1 and F1, those of the other transformer S2 and F2. If the voltmeter across the terminals S1 and S2 reads twice the voltage of either transformer, we connect terminal S1 to F2, the terminal F1 to S2. However, if the voltmeter reading is 0, S1 and F2 have opposite polarities. We connect S1 to S2, F1 to F2. The phasing of transformer with high voltage secondaries of primaries should be done with lowered excitation voltages in order to reduce high voltage shock hazard. Okay, now transformer loss. Okay, power losses. Okay, power losses in the transformer occur in the transformer core material and in the transformer primary and secondary winding. So eddy current loss. Okay, so I think that you know eddy current, otherwise I will discuss it in my channel. Eddy current, what is eddy current? So there is a formula of the copper loss. Copper loss is the power lost in the primary and secondary windings of the transformer. It is due to the ohmic resistance of windings. Formula is copper loss is equal to I square mu r mu, I square is rs. Okay, resistance. Okay, this is the total formula. Now we start a problem and then we will. Okay, problem is a 240 to 24 volt step down transformer has full load secondary current rating of 50 ampere. A short circuit test for copper loss at full load gives a wattmeter reading of 100 watt. If the resistance of the primary is 0.8 ohm, what is the resistance of the secondary and what is the secondary power loss? So solution is, we know that 100 watt is equal to, the formula is this formula copper loss is equal to, this is the formula. So I apply this formula. 100 watt is my watt meter copper loss. So 100 watt is equal to I square mu plus R mu plus I square S plus RS. Okay, so you see, according to the question, 240 to 24 volt. Okay, 224 volt. Now you see that is equal to is equal to 5 square. Okay, now you see that since full load secondary current 50 ampere, okay, 50 ampere is the secondary current, and the voltage ratio of the transformer is 240 to 24 volt. Okay, so now we can say that 24 to 40 to 24 or 10 to 1. Okay, and full load primary circuit is equal to 50 by 10 is equal to or 5 ampere. Okay, so now we have to I have to find out RS. RS is equal to, okay, 100 minus 5 square into 0.8 divided by 50 whole square. Okay, 50 whole square. So what is the answer? Answer is 100 minus 20 divided by 2500 is equal to 80 by 2500 is equal to 0.032 ohm. So power loss is equal to 50 square into 0.032 is equal to 80 watt. So friends, this is my total problem. I hope it is clear, and if any problem, please ask me. Thanks for watching. Because 0.8 ohm is already given, 0.1 ohm primary. Okay, primary is 0.8 ohm. So this is the total solutions.